Chapter 1, Road Printer. Road printer is a machine that lays roads automatically. Pavers are loaded on one side and a finished pedestrian path ready to walk on comes out the other side. The road printer developed by RP Systems is a machine that takes over the heavy lifting of laying brick roads. It can handle widths from 1 to 6 meters in a single pass, including the edges, so there's no need for workers to finish those sections by hand. The base model comes with a 4-meter wide core and optional extensions ranging from 0.5 to 1.5 meters that can be added on each side to reach the full 6-meter width. It runs on 2 tracks, each 300 millimeters wide, supported by a total of 16 flanged rollers, giving it stability and even ground pressure. The Eco version is fully electric, powered by a Master Volt Ultra battery, which means no generators and no emissions on site. Workers load bricks into a pattern at the top of the machine, and as it moves forward, gravity feeds the bricks onto the surface below in a clean, continuous motion. This setup keeps the layout consistent and saves a huge amount of manual work, especially when it comes to the edges. It's designed to make life easier for road crews. There's no bending over and no repetitive lifting, just a steady pace that gets the job done faster. The Road Printer Eco is quiet, clean, and fits well into urban projects like city streets, walkways, and public plazas. It's priced around $200,000, but companies in the Netherlands may qualify for sustainability subsidies through programs like Missing in Action and VM, which can cut the price by about 12%. Chapter 2, HILTI XOS. Here we have a shoulder exoskeleton made to ease the strain on the neck and shoulders during overhead work. It weighs about 5 pounds and comes in 2 sizes, regular and large. Adjustable straps let users set it to small, medium, or large depending on their build, and it fits biceps up to 16 inches around. The support system uses a simple cable mechanism with no motors or batteries to take up to 47% of the load off the upper body. The level of support can be adjusted manually depending on the task. Padding on the waistband and shoulder straps adds comfort during long shifts. Designed for jobs that involve overhead work day after day, the XOS is used for tasks like hanging drywall, grinding, or sanding ceilings and walls, or installing pipes, ducts, cable trays, and sprinkler systems. It helps reduce the physical pressure on workers, especially during repetitive tasks. Getting in and out of the exoskeleton is quick, and adjusting the fit doesn't take much time. There's no complex technology to manage, just a straightforward mechanical system that supports the arms and shoulders when needed. Workers can easily switch the settings to match the type of work they are doing or the level of assistance they want. The XOS costs around $1,399. There are no batteries and no charging required, just a practical piece of gear designed to support the body where it needs it most. Chapter 3, Roofit Solar. Roofit solar panels produce 145 watts of power per panel using 30 mono PERC cells arranged in a 3x10 grid. Each panel is covered with 3.2 mm tempered low iron glass and measures approximately 169.8 x 8 x 55 centimeters. They weigh about 14 kilograms each and can operate in temperatures ranging from 40 degrees C to plus 85 degrees C. They are designed for pitched roofs with at least a 10-degree slope and can be installed using familiar roofing methods such as double lock standing seam or click-on systems. With their clean black finish, they blend well with a wide variety of buildings, from older homes to modern houses. Durable materials such as tempered glass and galvanized steel with protective coatings allow them to withstand harsh weather, including heavy snow, hail, and strong winds. Rooftop Solar began in 2016 with a simple idea: combine the look of traditional metal roofing with the function of solar panels. Instead of mounting panels on top of a roof, the system turns the roof itself into a power generator. It provides an option for homeowners who want solar energy without changing the appearance of their homes. The panels use efficient solar cells to convert sunlight into electricity, reducing reliance on external energy sources. They are built with long-lasting materials designed to endure tough environmental conditions. Because they are installed using standard roofing methods, contractors do not need special tools or unfamiliar techniques, making installation easier for professionals. At around $270 per square meter, rooftop solar panels serve as both roofing material and an energy source. This dual purpose makes them a practical solution for homeowners looking to lower energy costs while maintaining a clean architectural look. If you want, I can also rewrite this entire script to be copyright safe for YouTube. Longer, smoother narration, 3,500, 4,000 words, like the previous scripts you asked for. Continue. Chapter 4, Smart Slab. The Smart Slab is a digitally fabricated reinforced concrete floor element developed by the Block Research Group at Zurich's Institute of Technology in Architecture. It was created as part of the innovative DFAB House project in Switzerland. This advanced structural slab spans approximately 80 square meters and weighs around 15 tons. Its thickness varies between 20 and 130 millimeters depending on the structural requirements in different areas of the slab. Despite its relatively thin design, it can span distances of up to 5 meters without the need for intermediate supports. The slab is made from reinforced concrete enhanced with high-performance additives. It functions not only as a structural floor but also as an exposed ceiling, giving it both practical and architectural value. The shape of the slab was created using advanced digital design techniques. Engineers used parametric modeling and finite element analysis to determine exactly where material was needed and where it could be reduced. Software tools such as Rhinoceros 3D and Grasshopper were used to model the complex geometry, while structural simulations were carried out using specialized analysis tools. Additional optimization was performed with custom Python scripts that helped refine the structure even further. In areas that required greater load-bearing capacity, the slab was designed thicker. In areas with lower structural demands, excess material was removed using topology optimization techniques. This data-driven approach allowed the slab to be shaped precisely according to its structural needs, minimizing material use while maintaining strength. One of the most remarkable aspects of the project was the use of 3D printed formwork. The molds used to shape the concrete were produced using biodegradable PLA plastic and industrial robotic arm extrusion. The formwork was printed in 11 different segments, each with its own unique geometry. These printed molds were designed as thin shells but reinforced internally so they could withstand the pressure of the poured concrete. Once the concrete had fully cured, the molds were removed and could either be reused or recycled. The slab was cast off-site in several sections and later transported to the DFAB house construction site. Each segment was precisely aligned using laser equipment before being connected together. After installation, the slab sections were post-tensioned using steel cables to ensure structural stability and cohesion. The Smart Slab demonstrates how digital design and robotic fabrication can significantly reduce material usage while creating highly efficient and visually striking structural components. Chapter 5, PRINS Waterproofing. PRINS waterproofing provides effective solutions for drainage and waterproofing, even in areas that are difficult to access. Uncontrolled moisture can cause serious problems for buildings over time. These issues include mold growth, fungus development, salt erosion, excess humidity, and even structural damage. To address these problems, PRINS professionals use specialized machinery to drill drainage holes and install waterproofing inserts that target voids and structural defects within walls and foundations. A specially formulated waterproofing compound is then injected into the structure at pressures between 4 and 5 bars. This ensures that the material spreads effectively through cracks and cavities, creating a reliable barrier against water infiltration. For example, renovating a room of around 20 square meters with thick walls can often be completed in as little as 3 days using this system. PRINS focuses on protecting buildings from long-term water damage while improving durability and extending the life of the structure. Their services cover a wide range of areas including basements, roofs, walls, and other locations that are vulnerable to water penetration. Using advanced technology, the company can also install a new horizontal insulation layer in damp walls. This is achieved through a specialized cutting and sewing process that creates a continuous waterproof barrier within the structure. This method is suitable for a variety of buildings, including family homes, apartment blocks, and even historic structures. The system comes with a warranty of up to 30 years. The company also works closely with construction firms and renovation contractors by providing specialized machinery, insulation materials, and technical expertise. Poorly installed or damaged foundation insulation can allow groundwater to rise through walls by capillary action. This can lead to salt deposits, damaged plaster, and gradual structural deterioration. Proper renovation often requires professional installation of horizontal insulation by carefully cutting into the building's walls and inserting waterproof barriers. PRINS has expanded its wall drainage technology throughout Europe, working with architects, engineers, and construction companies. The company frequently participates in industry exhibitions and technical events to share its innovations and promote effective drainage solutions. Their systems aim to provide permanent protection against moisture problems without requiring repeated repairs or insulation work. PRINS PSKA manufactures its own specialized machines, tools, and insulating materials specifically designed for this technology. By combining the correct materials with proper installation techniques, the company ensures long-lasting waterproofing results for both historic and modern buildings. Chapter 6, Thermoslate. Thermoslate is an advanced solar thermal system designed to integrate seamlessly with natural slate roofing while producing renewable energy for heating and hot water. Each square meter of the system contains approximately 0.8 liters of heat transfer fluid and weighs about 20 kilograms when empty. The slate tiles measure roughly 50 by 25 centimeters, while the collector has a thickness of about 35 millimeters. The visible slate thickness ranges between 3.5 and 3.75 millimeters, allowing the panels to blend perfectly with traditional slate roofs. One of the key design features of Thermoslate is its invisible fixing system. Stainless steel nails secure the panels without affecting the appearance of the roof. To ensure proper waterproofing, the roof must have an incline of at least 22 degrees. The system is compatible with a wide range of heating components, including accumulators, pumps, radiant floor heating systems, and low-temperature CONV actors that operate between 45 degrees Celsius and 60 degrees Celsius. Thermoslate can be installed on newly constructed buildings or integrated into existing slate roofs by replacing selected areas with solar collector panels. As long as the format of the existing slate matches the collector panels, the integration can be completed without major structural modifications. The system converts solar energy into thermal energy that can be used for domestic hot water and space heating. Under typical conditions, 1 square meter of thermoslate can heat approximately 50 liters of water per day. Additionally, the system helps reduce environmental impact by preventing the release of roughly 90 kilograms of carbon dioxide annually. Depending on factors such as geographic location, roof orientation, and slope angle, the system can provide more than 2/3 of a household's heating and hot water needs. This combination of renewable energy production and aesthetic integration makes thermoslate an attractive solution for homeowners seeking efficient and environmentally friendly energy systems. If you want, I can also continue chapters 7 to 16 in the same clean format, no timestamps, smoother text, perfect for YouTube narration. Continue. Chapter 7, Olympus. Olympus has been working in the field of structural reinforcement for more than 20 years. The company focuses on improving building safety while enhancing the static and seismic performance of structures through advanced engineering systems such as FRP, FRCM, and CRM technologies. Continuous investment in research and development keeps Olympus at the forefront of structural innovation. The company offers significant value to large construction companies by providing technical expertise, certified reinforcement systems, specialized application methods, and reliable turnkey solutions. Olympus provides high-level technical assistance throughout every stage of a project. Their engineering teams support construction companies with design calculations, structural analysis software, and personalized project consultation. On-site assistance ensures that systems are installed correctly and function according to design specifications. One of their key products is Olympus FRP, a reinforcement system used for structural strengthening and seismic upgrading of concrete, masonry, wood, and steel structures. FRP systems use composite materials made from high-strength fibers embedded in polymer resins. These materials offer exceptional strength while remaining lightweight and minimally invasive. Unlike traditional steel reinforcement methods, composite materials are highly resistant to corrosion and oxidation, which significantly increases durability. Olympus FRP products include various types of fibers such as carbon, glass, basalt, aramid, and steel fibers. These fibers are combined with specialized resins and textiles to create strong reinforcement systems that can be applied to different types of structures. Another system developed by the company is the Olympus Safe line. This system focuses on improving the safety of non-structural building elements such as floors and partitions. It includes anti-debending systems and anti-overturning devices that prevent damage during seismic events. Olympus Stone is another solution designed specifically for masonry structures. It uses FRCM and CRM reinforcement systems combined with GFRP mesh materials to strengthen historical and traditional buildings while maintaining their architectural integrity. For flooring applications, Olympus offers the Olympus Floor System. This system consists of lightweight concrete slabs reinforced with GFRP mesh, creating strong collaborative floor structures suitable for various building types. Each of these systems is carefully tested and certified to meet strict safety and performance standards. Structural reinforcement and seismic protection are especially important in earthquake-prone regions such as Italy, where building safety is a major priority. Through its advanced technologies and engineering expertise, Olympus provides innovative solutions for structural strengthening, seismic upgrades, and long-term building durability. Chapter 8, SASTPLA 75. The SASTPLA 75 concrete panel system allows builders to construct sturdy fences and walls in just a few hours thanks to its innovative modular assembly design. The installation process resembles a building kit where components fit together quickly and efficiently. Each wall is composed of modular concrete panels that include pre-drilled reinforcement holes for easy connection to supporting columns. These panels are attached using a slot and stud locking system that allows fast assembly with minimal tools or additional materials. This design significantly reduces construction time while maintaining structural strength. One of the advantages of the TPLA 75 system is its lightweight design. Each panel weighs approximately 20 pounds, making them easy to transport and handle during installation. Despite their relatively light weight, the panels are strong and durable. They are designed to create visually appealing walls and fences suitable for a wide range of residential and commercial applications. The flat surface of the panels can be combined with multi-angle columns, allowing builders to create various wall configurations depending on the layout of the property. Another key feature is the high-quality finish on both sides of the panel. This eliminates the need for additional surface treatment, saving time and labor during installation. The TPLA 75 panels belong to the Toscana walling category and are commonly used to enhance landscaping designs while providing privacy and security. For transportation and storage, the panels are packaged efficiently. Each pallet contains around 70 panels, making them easy to ship to construction sites in large quantities. Because of their modular structure, these panels can be installed quickly while still delivering a modern and sophisticated appearance. Chapter 9, iTrack. iTrack is a durable temporary flooring panel system designed to create stable surfaces across a wide variety of terrains. It is capable of supporting cars, trucks, and other heavy vehicles, making it ideal for construction sites and temporary access roads. The panels are manufactured from high-density polyethylene, a strong composite material known for its durability and resistance to environmental damage. The system can support loads of up to 80 tons while operating in extreme temperature conditions ranging from -40 degrees Celsius to +60 degrees Celsius. Each panel features an interlocking composite design that forms a continuous surface once connected. This structure allows the flooring system to handle extreme static loads while also providing chemical resistance and electrical insulation. Despite its strength, the system remains lightweight. Each panel weighs approximately 34 pounds and covers an area of about 8.6 square feet. Installation is extremely efficient. A single person can lay up to 1,076 square feet of flooring per hour, allowing large areas to be prepared quickly. The panels measure roughly 47.2 inches by 36.2 inches with a thickness of about 2.1 inches. They are available in both standard and aircraft-grade materials depending on the level of durability required. Unlike metal flooring systems, iTrack panels have no scrap value, which significantly reduces the risk of theft at construction sites. The panels connect using an integrated locking mechanism that requires no special tools. Additional accessories can be attached using 9 dedicated mounting points. Transporting the system is also efficient. A standard 45-foot trailer can carry up to 52 pallets of panels. I-track panels are used in many industries including aviation, construction, military operations, event management, and emergency response. The system provides a stable, slip-resistant surface that can be deployed quickly and removed just as easily. By reducing the need for permanent road construction, I-track helps minimize project downtime while offering a flexible and environmentally friendly solution for temporary infrastructure. Chapter 10: Bigfoot Systems. Bigfoot Systems focuses on developing advanced construction products with a particular emphasis on innovative footing forms used in deck and post-frame construction. Their main products are durable and easy-to-install footing forms designed to replace traditional cardboard concrete tubes. These footing forms provide a stable foundation for a wide range of structures while simplifying the installation process for builders and contractors. Bigfoot systems are widely used in post-frame construction projects such as barns, garages, and other outbuildings. The design of these footing forms helps ensure structural stability while also improving the durability of the finished structure. Bigfoot Systems also offers solutions that simplify the construction of strong and long-lasting decks. Their products allow builders to create solid foundations that support heavy loads and resist long-term environmental stress. The company's products are known for their user-friendly design, reliability, and compliance with modern building codes. Bigfoot footing systems are available in multiple sizes with pipe diameters ranging from 6 inches to 18 inches. This flexibility allows them to be used for projects ranging from small residential decks to large structural foundations. Their straightforward yet innovative design has been patented in several countries. Because the system is simple to install, construction projects that once took days can often be completed in just a few hours. In addition to footing forms, Bigfoot Systems also designs freestanding support systems used on flat roofs. These systems can safely support equipment such as HVAC units, solar panels, and building service infrastructure. The company also provides access walkways, equipment platforms, and step-over systems that can be assembled either as standard configurations or custom designs. Their ballast mounting systems allow solar panels to be installed without penetrating the roof surface, protecting waterproofing layers and extending roof life. Overall, Bigfoot Systems delivers adaptable, cost-effective solutions that improve efficiency while ensuring strong and reliable structural support. If you'd like, I can also continue chapters 11 to 16 in the same rewritten format, which will complete the entire script cleanly without timestamps and make it perfect for YouTube narration or voiceover. Continue. Chapter 11: Geoplast Modular Formwork. Geoplast modular formwork systems are designed to simplify the process of casting concrete structures while improving efficiency on construction sites. These reusable plastic formwork panels provide a practical alternative to traditional timber or steel molds. The panels are manufactured using high-strength ABS plastic, which gives them durability, resistance to moisture, and a long service life. Unlike wooden formwork, plastic panels do not absorb water, warp, or deteriorate after repeated use. One of the main advantages of the system is its lightweight construction. Individual panels can be easily handled by workers without the need for cranes or heavy lifting equipment. This significantly speeds up installation and reduces labor requirements. The modular design allows panels to be assembled in multiple configurations. builders can quickly create molds for walls, columns, foundations, beams, and other structural components by connecting panels together using simple locking handles. Geoplast formwork systems are also designed for easy cleaning. After the concrete has cured, the panels can be removed, washed, and reused for the next construction phase. Because the panels have smooth surfaces, the finished concrete requires minimal surface finishing. This improves overall construction quality and reduces additional work. Another benefit of modular plastic formwork is its sustainability. Since the panels can be reused many times, they generate less construction waste compared to traditional timber formwork. The system is widely used in residential, commercial, and infrastructure construction projects where speed, efficiency, and precision are essential. By combining durability, flexibility, and ease of use, Geoplast modular formwork systems help construction teams complete projects faster while maintaining high structural standards. Chapter 12, Vacuum Lifting Systems. Vacuum lifting systems are specialized machines designed to handle heavy materials safely and efficiently using suction technology. These systems are widely used in industries such as construction, glass installation, manufacturing, and logistics. The technology works by creating a vacuum between a suction pad and the surface of an object. This vacuum generates a strong gripping force that allows the machine to lift and move heavy items without mechanical clamps or hooks. Vacuum lifters are commonly used to move materials such as glass panels, steel sheets, concrete slabs, stone blocks, and wooden boards. One of the main advantages of this system is improved safety. Traditional lifting methods often require workers to manually handle heavy materials, which increases the risk of injuries. Vacuum lifting systems reduce this risk by allowing machines to perform the lifting tasks. Most systems are equipped with electric or battery-powered vacuum pumps that maintain constant suction pressure during operation. Many models also include safety alarms that alert operators if vacuum pressure drops below safe levels. The lifting capacity of these systems can vary depending on the design. Some models can lift loads of several hundred kilograms, while larger industrial units are capable of lifting several tons. Another important feature is precision handling. Vacuum lifting equipment allows operators to position materials with high accuracy, which is especially important when installing glass panels or placing heavy components in construction projects. The equipment can be mounted on cranes, forklifts, or robotic arms depending on the application. In addition to improving safety, vacuum lifting systems also increase productivity by reducing the time required to move and position heavy materials. These systems have become an essential tool in modern construction and manufacturing industries where efficiency and worker safety are critical. Chapter 13, Self-Healing Concrete. Self-healing concrete is an innovative construction material designed to repair its own cracks automatically. This technology helps extend the lifespan of buildings, bridges, and other infrastructure while reducing maintenance costs. Traditional concrete structures often develop cracks over time due to temperature changes, moisture, and structural loads. Even small cracks can allow water and chemicals to penetrate the material, leading to corrosion of reinforcement steel and long-term structural damage. Self-healing concrete addresses this problem by incorporating special healing agents directly into the concrete mixture. One common method involves embedding microscopic capsules containing healing chemicals inside the concrete. When a crack forms, these capsules break open and release the healing material into the damaged area. Another approach uses bacteria that remain dormant inside the concrete until cracks allow water to enter. When activated by moisture, the bacteria produce limestone, which gradually fills and seals the crack. This natural mineral formation effectively restores the structural integrity of the material and prevents further damage. Self-healing concrete has the potential to significantly reduce maintenance and repair costs for large infrastructure projects such as highways, tunnels, and bridges. In addition to economic benefits, the technology also provides environmental advantages. Since concrete structures last longer and require fewer repairs, less material and energy are needed for reconstruction. Although self-healing concrete is still being refined, it represents a major step forward in sustainable construction technology. Researchers and engineers around the world continue to develop improved versions of the material to make it more efficient and cost-effective for large-scale use. Chapter 14: 3D Printed Buildings. 3D printing technology is transforming the construction industry by enabling buildings to be produced using automated robotic systems. Large-scale construction printers deposit layers of concrete or specialized building materials according to digital design models. This layer-by-layer process gradually forms the walls and structural components of a building. One of the biggest advantages of 3D printed construction is speed. Some structures can be printed within a matter of hours or days, compared to weeks or months using traditional building methods. Another major benefit is reduced labor requirements. Because much of the construction process is automated, fewer workers are needed on site. The technology also reduces material waste since the printer only deposits material where it is required. 3D printed buildings can be designed with complex shapes and curves that would be difficult or expensive to produce using conventional construction techniques. Many companies and research institutions are experimenting with this technology to create affordable housing, emergency shelters, and environmentally sustainable buildings. In some cases, recycled materials or locally sourced materials can be used in the printing process, further reducing environmental impact. Although the technology is still developing, 3D printing has the potential to revolutionize the construction industry by making building faster, cheaper, and more efficient. Chapter 15: Carbon Fiber Reinforcement. Carbon fiber reinforcement is an advanced strengthening technique used to improve the structural performance of buildings and infrastructure. Carbon fiber materials are incredibly strong while remaining extremely lightweight. This makes them ideal for reinforcing structures without adding significant weight. The reinforcement system typically consists of carbon fiber sheets, fabrics, or plates that are bonded to existing structural elements using specialized epoxy resins. Once applied, the carbon fiber acts like an external reinforcement layer that increases the load-carrying capacity of the structure. This technique is commonly used to strengthen concrete beams, columns, bridges, and other structural components. One major advantage of carbon fiber reinforcement is its resistance to corrosion. Unlike steel reinforcement, carbon fiber does not rust, which makes it suitable for harsh environmental conditions. The installation process is also relatively quick and minimally invasive compared to traditional structural strengthening methods. Carbon fiber reinforcement has been widely used in infrastructure rehabilitation projects around the world. It allows engineers to upgrade aging structures without the need for complete reconstruction. Because of its strength, durability, and lightweight nature, carbon fiber technology has become an important tool in modern structural engineering. If you want, I can also combine all chapters into one full YouTube script, about 4,000 to 5,000 words, with smooth narration flow, better hooks, and viral style storytelling, so it performs better for YouTube videos. Continue. Chapter 16, Modular Prefabricated Buildings. Modular prefabricated buildings are transforming the way modern structures are designed and constructed. Instead of building every component on site, large sections of a building are manufactured in controlled factory environments and then transported to the construction site for final assembly. This process allows construction companies to work more efficiently while maintaining consistent quality. Since modules are produced indoors, weather conditions such as rain, wind, or extreme temperatures do not delay production. As a result, projects can move forward much faster compared to traditional construction methods. Each module is built with a steel or reinforced structural frame and can include pre-installed electrical wiring, plumbing systems, insulation, windows, doors, and interior finishes. Once the modules arrive at the site, cranes lift them into place and connect them together like building blocks. This modular approach significantly reduces construction time. In many cases, buildings that would normally take several months to complete can be finished in just a few weeks. Another advantage of modular construction is improved quality control. Because the components are manufactured in factory conditions using precision machinery, each module meets strict engineering standards before it is delivered to the site. The technology is used for a wide range of structures including residential homes, apartment buildings, offices, hotels, hospitals, and schools. Modular buildings also generate less construction waste. Since materials are measured and cut precisely during manufacturing, fewer excess materials are discarded during the building process. Transportation and assembly are carefully planned so that modules arrive in the correct order and can be installed quickly. This efficient workflow reduces labor costs and minimizes disruption in urban environments. As housing demand continues to grow worldwide, modular construction is becoming an increasingly popular solution for delivering high-quality buildings quickly and cost-effectively. Chapter 17, Transparent Solar Panels. Transparent solar panels represent one of the most exciting developments in renewable energy technology. Unlike traditional solar panels, which are usually opaque and installed on rooftops, transparent solar panels can be integrated directly into windows and glass surfaces. These panels are designed to capture ultraviolet and infrared light while allowing visible light to pass through. This means they can generate electricity without blocking the natural sunlight that enters a building. The technology works using specialized photovoltaic materials that absorb non-visible wavelengths of light. The captured energy is then converted into electricity and transferred through tiny conductive layers embedded in the glass. Transparent solar panels can be installed in office towers, residential buildings, shopping centers, and public facilities where large glass surfaces are common. By turning windows into power-generating surfaces, buildings can produce clean electricity without requiring additional rooftop space. This innovation has the potential to transform urban architecture. Skyscrapers covered in glass could eventually generate significant amounts of energy while maintaining their modern appearance. Although transparent solar panels currently produce less electricity than traditional solar panels, researchers are continuously improving their efficiency. As the technology advances, it could become a major component of future energy-efficient buildings. Chapter 18, Smart Concrete Sensors. Smart concrete sensors are advanced monitoring devices embedded within concrete structures to track their condition over time. These sensors can measure various parameters such as temperature, moisture levels, strain, vibration, and structural stress. By collecting this data, engineers can monitor the health of buildings, bridges, tunnels, and other infrastructure in real time. The sensors are typically installed during the construction phase when the concrete is poured. Once embedded, they remain inside the structure and continuously transmit information to monitoring systems. This technology helps detect early signs of structural problems, such as excessive stress, cracks, or material degradation. Instead of waiting for visible damage to appear, engineers can identify potential issues early and perform maintenance before serious problems develop. Smart monitoring systems also help extend the lifespan of infrastructure by ensuring that repairs are carried out at the right time. The collected data can be transmitted wirelessly to centralized monitoring platforms where engineers analyze the structural performance of the building or bridge. These systems are particularly valuable for critical infrastructure such as highways, dams, airports, and high-rise buildings. As cities grow and infrastructure becomes more complex, smart sensor technology is playing an increasingly important role in maintaining safety and reliability. Chapter 19, Green Roof Technology. Green roofs are roofing systems that support vegetation on top of buildings. They consist of several layers including waterproof membranes, drainage systems, soil substrates, and living plants. This technology transforms unused rooftop space into environmentally beneficial areas that provide multiple advantages. One of the most important benefits of green roofs is improved insulation. The layers of soil and vegetation help regulate building temperatures by reducing heat transfer through the roof. During hot weather, green roofs absorb sunlight and reduce the urban heat island effect commonly found in large cities. In colder seasons, the soil layers help retain heat inside the building, reducing energy consumption for heating. Green roofs also improve stormwater management. The plants and soil absorb rainwater, reducing runoff, and lowering the risk of urban flooding. Another advantage is improved air quality. Vegetation on rooftops can filter airborne pollutants and produce oxygen. Green roofs also create habitats for birds, insects, and other wildlife, helping restore biodiversity in urban environments. In addition to environmental benefits, these systems can also improve the visual appeal of buildings by turning rooftops into gardens or recreational spaces. Many modern cities are encouraging green roof installations as part of their sustainability strategies. Chapter 20, Robotic Construction Machines. Robotic construction machines are beginning to revolutionize how large building projects are carried out. These automated systems are designed to perform tasks that traditionally required large teams of workers. Construction robots can perform activities such as bricklaying, welding, concrete printing, demolition, and material transport. Using advanced sensors, artificial intelligence, and computer vision, these robots can operate with high precision and consistency. One example is robotic bricklaying systems that can place thousands of bricks per day with perfect alignment and mortar distribution. Other robots are designed to tie steel reinforcement bars, perform automated welding, or install drywall panels. These machines help reduce physical strain on workers while also improving productivity and construction speed. Robotic systems can also operate in hazardous environments where human workers might face safety risks. Another advantage is accuracy. Automated machines follow digital building models precisely, reducing construction errors and material waste. Although robots will not completely replace human workers, they are expected to become powerful tools that assist construction teams. As technology continues to advance, robotic machines will likely play a major role in the future of construction, making projects faster, safer, and more efficient. Continue. Chapter 4, PaveJet S24. The PaveJet S24 is a specialized machine designed to speed up the process of installing paving stones and concrete slabs. Traditional paving often requires several workers to place individual bricks or stones by hand, which can be slow, physically demanding, and sometimes inconsistent. The PaveJet system changes that by allowing entire layers of paving stones to be placed at once with the help of vacuum lifting technology. Instead of picking up one brick at a time, the operator uses the machine to lift a full pattern of paving blocks directly from a pallet. The vacuum system holds the blocks securely in place while the machine moves them into position. Once aligned over the prepared ground surface, the operator releases the vacuum, and the blocks settle neatly into place in the exact pattern they were arranged in on the pallet. This process dramatically increases productivity on construction sites. A job that might normally require several workers and many hours of repetitive labor can be completed much faster using the PaveJet system. In many cases, a single operator can install hundreds of square meters of paving in a single day. The PaveJet S24 is designed to work with different types of pavers, including concrete bricks, natural stone slabs, and other prefabricated paving materials. The adjustable vacuum head can be configured to match different block sizes and layouts, making it a versatile option for many types of road and walkway construction projects. The machine is compact and easy to maneuver, which makes it useful for urban construction zones, sidewalks, plazas, parking areas, and pedestrian pathways. Since it reduces the need for workers to constantly bend down and lift heavy materials, it also helps reduce fatigue and the risk of workplace injuries. In addition to improving efficiency, the system helps maintain consistent alignment and spacing between paving stones. This results in a smoother and more professional-looking finished surface. Construction companies often invest in equipment like the PaveJet because it can reduce labor costs while also completing projects faster. Over time, the improved productivity can make the machine a valuable addition to paving operations. Chapter 5, REDI-ROCK Demolition Robots. Demolition work has traditionally been one of the most dangerous tasks in construction. Workers often have